Yesterday I did a workshop with Peter Forbes. He gave a pretty moving presentation at the plenary yesterday, and one of the questions he asked us to consider during that workshop was, whose shoulders is our work standing on? And my opportunity to be involved in this project in KAUST makes me feel like a bit of a rock star. And I see rock stars doing these things on stage where they take a photo of their audience. And I thought I might do the same, because the people whose shoulders I'm standing on, that's you people. So everyone just get together, just briefly. Thanks, and be on all my socials. So one of the things I want to talk about is trying to address the issue of scale. So this is a big project, and one of restoration's greatest challenges is how do we scale up these activities to more than the small scales that have been operating over the past couple of decades. This figure has already been introduced a couple of times, and what I'm going to talk about today is this little section down here, the ocean-based nursery and in-situ restoration that we're doing at Shusha Island. Where are we going? So I arrived at KAUST a couple of years ago, and it's located on the shores of the Red Sea, and it's about an 8-hour drive to get to Neom. We work at this little island, which is offshore, about an hour's drive from our land-based nursery. So it's a pretty complicated environment, and pretty remote. So we had to deal with those challenges. And it was myself and a few colleagues who arrived there, and there'd been an extensive amount of baseline data that had been collected on the site, but nothing in the way of restoration infrastructure had been implemented. And so this is less than 2 years ago. So it was like, great, where do I start? Or where do we start? Not just me. As most restoration practitioners know, you need to understand your site. And Shusha has a wide variety of different landscapes and different responses to, the local environment. So we started by doing something, to trialling and testing a range of ideas that were suitable for the location. We used efficient methods that were going to support scaling and support both our ecological and workflow aspirations, like Tom just spoke about in the previous presentation. Within 12 months, we trialled about 8 or 9 different methods and reduced this to 4 that we would move forward with in the space of just 12 months. The goals of this project are big. Anybody who's been in corporate workshops probably heard the term BHAG. Anyone? Big, hairy, audacious goals. And so, 100-hectare site, we're trying to develop the next generation of tools for restoration. Annually, we're going to propagate 100,000 corals in situ and another 400,000 at our ex situ facility that's already been showcased. This year alone, we've got 60,000 corals in our nurseries, and 20,000 will be outplanted by the end of this week, with a target of around 2 million by the end of this decade. And we're also doing a lot of structural enhancement that Mark spoke about earlier as well, implementing artificial reef structures to enhance the environment and the landscape at Shusha. Now, most people leave their acknowledgements to the end of their presentation, but none of this would be possible without an amazing team of people that have been brought together to deliver on this project. We come from a variety of different backgrounds and life histories, but everyone is passionate. And if anything that I learned about yesterday's plenary talks and the information that we received throughout the day is that it's really about people that are going to change the trajectory of restoration. And so we can have all the science in the world, but if you don't have the passionate people like the people on the screen here or the people in the room here, then it's not going to count for very much. We also have to look at how do we reach scale, and there's been a lot of organisational competencies that have come into building this sort of project and delivering these sort of numbers. We have a range of vessels, a large team that I've just spoken about, and we work 7 days a week, ideally throughout the year, but sometimes weather and other things hold us back. And so up until now, we've pretty much been operating at what we would consider normal in situ restoration activities. This is growing coral in nurseries, outplanting it onto the reef substrate or onto artificial reef structures. But we're also doing a lot of fast fail trials to learn what works and what doesn't work at this site, and Evelyn, one of my colleagues, will talk about that shortly. We do a lot of, we've been trialing different methods and techniques that I spoke about, and you can see in these photos and this video, a lot of the work we're doing involves, you know, your standard PVC and cable ties and these sort of things, but all of this development and trialing and testing and tweaking has led to what Tom just presented in the previous presentation. It has guided our development of the next generation of in situ and ex situ restoration tools that we're going to use as we go forward. As I said, we work with the team extensively that have come from a variety of different backgrounds, trying to make sure we're building capacity both internally within the kingdom through the Elevate trainee program, but also externally with local and international contractors. So I just want to run you through one sort of case study as a bit of an example. So we started with nurseries that were tied together, and we had floating lines and some floating tables that you can see in the picture on the left there. And these were anchored down the bottom at about 11 metres. And these had integrated components to work in with the system that Tom spoke about before, that you can transport them from the boat to underwater, from ex situ to in situ, and these are easily transportable by divers. And we used hanging techniques that are really popular in many parts of the world, and we trialled twisting the corals into the rope, or using monofilament that's popular in the coral nursery tree design. And we quickly found out that the ones that were twisted into the rope didn't really work, so we quickly eliminated that as a method. And then we had these lines that were hanging off a PVC pipe that was mobile in the water, but the corals that were on that concave line would often bump into one another, and it caused them to be a little bit damaged and compromise their health and survival. And so not going backwards, we're going to go forwards, and we developed these rigid aluminum frames where the corals hang much more neatly, much more cleanly, and don't compromise each other's health. And we've also looked at the site specificity of this location. So there's variable temperatures that are quite distinct between summer and winter, and we found that we were getting quite slow growth rates at the depth that they were at. So we came up with a new design to solve this problem, which allows us to adjust the depth for the summer and winter times. So we'd lower them down during summer to mitigate some of the UV and temperature stresses, and bring them up in the winter so they can maximise their growth rates during those generally slower growing months. And we've still got to work out whether that's an effective strategy, but so far it's proving to be quite a good approach. To the point now where we have these triple-story integrated modular systems that are optimised for efficient logistics and workflow and are very site-specific. And we have the line nurseries above the trays because they don't cast as much shadow as you might get if you put a fixed structure there. And Tom's already spoken about how we're innovating for the future, so a lot of this work has guided that. And that's really the key of what we've been doing as a field team for the KCRI project. We're innovating at every level. We're looking at the minute details and trying to figure out ways that we can improvise, improve, and make them more effective for our users. You know, the coral plugs, we've gone through a variety of iterations to end up with the one on the right. Mid-water storage facilities so we can propagate corals on the boat and then hang them underwater before we transport them down to those nurseries. Ecologically, you know, we've been looking at doing more propagation underwater during the warm months so they're not exposed to aerially that corals being propagated on the vessel are. And we're also looking at some thermal mitigation strategies. You know, we've implemented shading, I just spoke about the lowering and raising of the nursery systems as well. So it's really been a key component, and the team that I spoke about earlier are all delivering and sharing their knowledge from past experience so that we are coming together, collaborating, and delivering this, what is going to be, well, which already is, a world-class project. And the other thing we talked about briefly too was Structural enhancement. So we're using steel frames, which are quite common throughout many restoration projects around the world. Some of you are probably familiar with the Mars restoration strategy. So we've been implementing those low relief strategies, but we're also working with a company in Melbourne, Australia called Reef Design Lab for these diver deployed and constructed artificial reef structures. These particular ones here that you can see in the video, they're about 3 meters tall, and they get bolted together underwater, so that it means you don't have to worry about cranes and large infrastructure to deploy them. It means you could probably implement them in more dynamic environments in different reefscapes around the world. So far, they've been proving really successful in the short time we've had them there, and getting a lot of fish recruitment, and we're really excited to see how they're going to develop over the next few years. So in conclusion, we're trying to build effective in situ coral propagations at scale. We've got significant goals, but with an amazing team of dedicated people, really well resourced and supported by the Kingdom in partnership with NEOM, and with really adaptive innovation, we are building what we hope will be the next generation of tools for in situ active reef restoration of coral reefs around the world. Thank you very much.